Okay guys, before we tackle this next problem in the NUPOC video study guide, I just want to say now that we're back making some videos, a lot of them are going to come pretty fast here, so if you guys aren't subscribed, I'd suggest go ahead and do that. You can either click this button right here or click the button down below the description. I don't have a real regular schedule for producing these videos. But there's going to be a lot coming in the next few weeks and months, so it's probably better just to get the email updates on that instead of having to check back at the channel every couple of days. Also, next month is going to be the 1-year anniversary of the channel, so there's a couple big things coming up. I got a couple fun sort of special releases that'll happen around then, so subscribe so you know when that happens as well, because I'm sure most of you will be pretty excited about that. Anyways, let's tackle this next problem. So continuing from the last video where we said we wanted to get into some more basic circuits for some of the people who are not electrical engineers but who may be getting some of these problems in their interviews. We've got this question from Guide 2, the second Navy study guide in the electrical engineering section. It's actually question 2 in that section, and it gives us these two circuits. Let's call it circuit A and circuit B, and asks us find the voltage and current of R1, resistor 1 here. So that's this resistor in circuit B and this resistor in circuit A. So let's take a look at circuit A first, right? So we're given some known voltage here. I mean, we don't know what it is, but we can assume it's given, and we know these resistances. And I'm going to label this current here, I'm going to label that I, and I'm going to label this current here that we're interested in I1. Now this one is actually pretty simple. We don't even really have to worry about R2, right? Because we know that if this is V here, if this voltage is V, then that same voltage V appears across this resistor. So we can actually just say V1, the voltage across R1, is just V, whatever that is. So we can say V1 equals V. Okay? And I1, well, we can just say, we know that voltage V equals current I times resistance R. So, we just divide both sides by R, and we can just say that I1 equals V, which we know, divided by R1, which is also assumed to be a known in this circuit. Okay, that's pretty straightforward. We didn't even have to deal with R2 at all. Okay, so they might give you a problem maybe where you have you have 10 other resistors out here, right, all in parallel. And if they're asking about R1, don't worry about all those resistors going off to the right, So let's take a look at circuit B. All right, a little bit different. We've got a series wiring. So now, instead of having the same voltage across both the resistors in the parallel case, now we have the same current, I, going through both resistors. We don't know what I is. We can sort of assume that, V is some sort of given, but well, I guess we could say that I, again using V equals IR, since resistors add in series, we can say that V, this total voltage here, is equal to the sum, the total voltage here has to be equal to the sum of the voltage drops across the two resistors, so that's V1 and V2, and we know that V1 equals I, the current through the resistor, times R1, and V2 equals I, again same current, times R2. So when we write V equals V1 plus V2, right, this source voltage must equal all the voltage drops on the resistors. That's Kirchhoff's voltage law. Over here you could say that the sum of the currents at this node, so the sum of the currents entering, I, must equal the sum of the currents leaving, so I1, and if we had I2 here, that's Kirchhoff's current rule, so you may want to look those up. I'll do a video on those in the coming days as well, the Kirchhoff's current law and Kirchhoff's voltage law. Getting back to this, though, we just sub in V1, our expression for V1 here, our expression for V2 here. We collect terms, right? And we can just say this is I times R1 plus R2. Okay. So now we actually can move this R1 plus R2 to the other side of the equation, and we're going to write I equals V over R1 plus R2. That's an R2, right? And now we know what I is in terms of V. So I we don't really know, could be something, whatever. We don't really know what it is offhand, but we sort of know what V is. We assume that's a given. So now we have I in terms of V. Let's just go and sub this right back into this equation here, and we're going to get, let's write it over here, we're going to get V1 equals V, I'm going to pull the V out to the front, times R1 over R1 plus R2. And this is, for electrical engineers, they know this is sort of like the voltage divider equation. This kind of circuit, this kind of series circuit is called a voltage divider because it divides the total voltage among the different resistors. And so what will happen is the voltage across any resistor is the total voltage times that resistor divided by the sum of all the resistors. So again, you might get a problem where there are like 10 resistors out here in series, and then ask you what's the voltage across this one. Well, it's the total voltage times that resistance divided by the sum of all the resistances, so R1 plus R2 plus R3 plus R whatever. Alright, so that's it. I hope that helps with some more basic circuits. Again, a lot of the videos coming up are going to come fast, and we got some special events coming up for the 1-year anniversary of the channel next month. So go ahead and make sure you subscribe so you don't miss any of these upcoming videos. It's a lot easier to just get the notifications than have to come back and check to see what kind of problems we're doing. So anyways, I hope this helps, and I'll see you in the next video.